All right, so now we're going to continue recording, and we're going to talk about centrifugal pumps. Now, we already did discuss centrifugal pumps with my little. Here is an impeller in a centrifugal pump. I think you guys should probably get this, but this book doesn't really hit on them because the book is more about power transmission. Centrifugal pumps are usually used for thinner fluid than hydraulic, right? They're used for a lot of chemicals, but more pumps than anything else are used just to push water down the line. So centrifugal pumps are typically used for lower viscosity materials, and water is probably the most common thing. They do hit on a couple key topics, though. Number one, you have to often prime the pump. In other words, if you don't have some liquid in that pump, when that disc starts spinning, it won't push on anything. It'll just be an air pocket around the disc, and the pump won't do anything. All right? So you often need a way to get liquid into the pump to start it running to create enough pressure to pull more liquid into the pump, or vacuum in this case. Another important concept for centrifugal pumps is the idea of cavitation. Cavitation is a problem. If you hear this thump, 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 thump sound from one of these, it means that you're creating vacuum in the pump impeller, right inside the pump housing itself, right against the impeller. These are like tiny little explosions right on the surface of the impeller. And they can actually destroy a steel impeller because there's so much power involved in these little vacuum explosions. So you can create cavitation by having too much back pressure, by having clogged filters, and a variety of other things. If you do have a cavitating pump, you need to shut that pump down as quickly as possible. So let's talk about section 11.2, pump specifications. This is where the book dives into all of these calculations, which I don't think are important. So we're not going to really dive into them. I'm going to ask you some questions about pumps, but I'm not going to ask you to run anything other than a basic calculation from this section. I will mention, though, some of the key factors in pumps. One of them is how much volume it delivers. The volume of the pump is very, very important. For instance, if I have these giant old hydraulic cylinders that need to be pushed out, if my hydraulic pump does not deliver enough volume to push out those cylinders quickly enough, then I'm going to have a system that isn't going to work well. All my hydraulic cylinders will be too slow for my application. So I need enough volume and or some other means to deliver the amount of hydraulic fluid I need. So that delivery of volume is very, very important. The other pump rating, which is also critical, is the power of the pump. And the book kind of makes this a little bit vague, but the most important factor in calculating pump power or choosing the right pump is horsepower. You're going to see a lot of different rules of thumb around horsepower, and we're going to see a couple tables when we get to fluid power class where you need to select the correct horsepower pump based on certain other characteristics of how you want that system to operate. So horsepower is probably the most important thing when it comes to pump specification. So all I really want you to do in this section is understand these key terms. The delivery or volumetric delivery of the pump is critical. The power is critical, and specifically the horsepower of the pump is critical. And the book kind of makes it clear that horsepower of the pump is always slightly less than or equal to, or actually usually slightly less than or much less than the horsepower of the motor that you're running. You can never get as much horsepower of the pump as the motor that you're using to push that pump. So it's critical to have the right motor running the right pump. So the last section that I'm going to spend the last section on hydraulic pumps is pump troubleshooting. So we've already touched on a lot of these, so I'm just going to use this as sort of a reminder. Some key factors for pump troubleshooting. The book says the number one reason for pump failure is bearing failure. And this is probably true for pumps that are well maintained on clean hydraulic systems overall. Bearing failure is the reason why it will fail over time. If they tend to run hot, the bearings will fail faster. Bearings will wear over time, even if you run the pump perfectly. So bearing failure is the most common thing. And the book goes through a couple reasons why bearings may fail more quickly, which are good. The most common reason for pump failure, in my experience, are seals, especially for the piston pumps. Those little valves seat against little seals, and those seals tend to fail over time. And so the seals will fail faster if you've got more grit or gunk going into that pump, causing problems with the seal of that particular valve or on the outside edge of the pump. So the more dirt you run through a pump, the faster it will fail. The book also talks about kind of major issues like fluid reservoir. You've got to have enough liquid in your fluid reservoir. This is especially true for hydraulic pumps overall. You've got inlets that need to have filters on them to keep the pump clean. Those filters could clog, so that would create a problem as well. And just like we mentioned earlier, a hydraulic pump will begin to cavitate the same as a centrifugal pump. And if you have a clog on the inlet, anywhere on the inlet. So inlet failure, is it caused by your strainer filling up? You got to keep your strainers clean. That's common standard maintenance for any kind of hydraulic pump system. Check your filters, check your strainers. We did talk about vane spring failure. Now another thing down here I highlighted is sometimes you get major problems on your shaft and you get keyways that shear off. Those are just soft steel keys. As we learned in the lab, sometimes they just shear off if there's too much force over them. Sometimes the steel begins to develop some flaws just by time and force. And the most common thing is set screws become loose. So you should always check to make sure your set screws are tightened and stay tight. It takes usually a long time for a loosened set screw to completely drop out, and then even a longer time for the keyway to migrate up or down the, a key to migrate up or down the keyway. So that could occur as well. So these are all slow failures, which if you checked it every few weeks, you probably can catch and fix. So that's why you need to do inspections on pump systems.